Hello friends, today we are going to start examples on Z transform. But now including ROC. So we will calculate Z transform X of Z and ROC of the Z transform. So we'll see some IMP examples of Z transform which are asked in GTU exams repeatedly. So do not bother about GTU exams. If you follow this technique of solving the Z transform, then we will sure get the full marks. So let us consider the mark weightage of examples related to Z transform. So we should consider the X of Z and ROC both combined gives the full mark for our exam. So it is up to 5 to 7 marks of each example. So we should consider maximum 7 mark question from Z transform most IMP, X of Z and ROC both will give the 7 marks. So in first example, find Z transform and comment on ROC for given sequence. So we'll see the sequence X of n is a raised to n u of n. So over here we'll consider the infinite duration sequence a raised to n u of n, where the u of n is a unit step signal starting with 0 to infinite. So the limit of u of n is n greater than or equal to 0. So let us first understand what is the meaning of this X of n. So by considering the u of n limit, means for n greater than or equal to 0, the a raised to n u of n is now a raised to n, where the u of n is 1 for the period n greater than or equal to 0. So now a raised to n becomes for n greater than or equal to 0, and for otherwise case the amplitude is 0. So we'll see the otherwise case is 0. So this is the actual signal given to us. So X of n, a raised to n, u of n, it means the a raised to n for the period n greater than or equal to 0. So it will look like this. So we consider a raised to n, the n is starting with 0 to infinity. This is the limit of n. So the value of a raised to n will be like this. So it's exponentially decreasing graph as the a raised to n. So we are considering a raised to n as this type of signal. So the limit is 0 to infinity. So now we'll first see what would be the step of solution. Now to solve this example, we should follow this step to get full marks in GTU exam. So we can easily get full marks in GTU exam if we follow the steps effectively. So say step 1 is always common in every example of Z transform. It is standard definition of Z transform. So we should consider first in step 1 the standard definition of Z transform is x of Z is equal to summation limit n tends to minus infinity to infinity x of n Z raised to minus n. So this will be the step 1 for every example of Z transform. So after that, the step 2 is to consider the x of n. Now for step 2, given x of n is now a raised to n for n greater than or equal to 0. If we say this is the equation number 1, so by putting this value x of n in equation number 1, say therefore from equation 1 we get x of z is equal to, now the limit of n would be the limit of x of n, as the a raised to n is the scope for n greater than or equal to 0. So the whole summation will limit to 0 to infinity, as this is the non-zero values starting with 0 to infinity. The rest of the left hand side of this x of n will be 0, so no need to consider the x of n in that side. So x of n into z raised to minus n. Now putting this x of n with this 0 to infinity, the value is a raised to n. So in the next step, the value of x of n becomes summation n equal to 0 to infinity x of n is now a raised to n z raised to minus n as it is. So this will become the a raised to n z raised to minus n. So if we elaborate this summation, then one by one we will put 0 to infinity 0, then 1 in place of n. We will get some series of values, but this will goes to infinity, so we cannot calculate the absolute value of this summation. So to calculate absolute value, let us consider some power series equation. That is, if the power series is starting with 0 to infinity, the format is a raised to n, then the absolute summation of this type of series, if we consider 0 to infinity, then when we put 0, that is a raised to 0, then a raised to 1, then a raised to 2, and so on up to infinity. But this will give the absolute summation as a 1 upon 1 minus a, condition mod a must be less than 1. So this is the solution of a raised to n type series. So this is nothing but the similar kind of series we are having in Z transform. So n is equal to 0 to infinity, n is equal to 0 to infinity, and this term is nothing but the power of n. So we will modify in next step the power of n, then this equation becomes n equal to 0 to infinity a raised to n is a, and z raised to minus n is in z inverse and raised to n. So now this will become n is equal to 0 to infinity a raised to n type solution. So now it is very easy. A is nothing but a z inverse in this equation. So now put a is equal to a z inverse, capital A is equal to a z inverse. So now the solution of this equation will be 1 minus 1 upon 1 minus a z inverse, and the same condition will follow. The mod a z inverse must be less than 1. So now this is the solution of given x of n, that is the only x of z. But now, as we know what is the ROC and what is the significance of ROC, we have already discussed in our previous lecture. So now to consider the value of ROC, let us consider the step number 3, comment on ROC. That is the most important point of every example, the region of convergence. Now how to calculate ROC for a given x of z? So for that we have to consider the limit of finite series, or the limit of the x of z, where the sequence, this answer becomes finite. So as per this solution, a z inverse must be less than 1. It is the condition for making x of z finite. So ROC is again a definition, the region of all set of z values for which this solution will be finite. So to make this finite, we will consider AZ inverse as our reference point. So as if AZ inverse is less than 1, now to solve this, let us say it is A is less than mod Z. So this can be written as a mod A less than mod Z. So this can also be written as mod A, say mod Z is greater than A. So this is the condition of ROC, that all the Z values must be greater than the value of A. So how to plot this value? To plot this value, first we will consider the Z plane, imaginary part of Z, real part of Z, and by considering the reference of A radius, will make a reference circle A, and now the condition is that all the Z values or set of Z values which are greater than A. So if this periphery will consider is the radius A, that is the distance from origin is radius A. So above this or greater than this means the outer circle area or the outer part of this circle becomes the region of convergence for given sequence, as the mod Z or all the Z values which are greater than A, so it would be the outer side of the circle. So all the region up to infinity beyond the outer side of circle radius A becomes the ROC of given x of z. So x of z is 1 upon 1 minus AZ inverse, and the ROC is the outer circle region of mod A radius circle. So this way we can calculate the x of z, the z transform of given sequence x of n, that is u raised to n u of n for this case, and then we will get the ROC by considering AZ inverse less than 1 formula, and AZ inverse less than 1 formula will give the final value, that is mod z is greater than A, and that is the outer circle area, that is this region of convergence for a given x of z. So this is the method of how to solve Z transform examples including x of z as well as ROC. So this whole example will last for 5 to 7 marks in our GTU exam. This is also can be asked in combination with other x of n, so x1 of n, x2 of n, and so on. So the maximum weightage of this type of example is 7 marks. Okay, so now we will see the next type of example based on the same concept of Z transform, but the condition for this second example is some different. So let's find out Z transform and comment on ROC for given sequence. Now the given sequence is x of n b raised to n u of minus n minus 1. The previous one was a raised to n u of n minus u of n. So now we will consider the u of minus n minus 1. So it is nothing but the signal u of n is first folded and then after shifted left by one sample. So the fashion of u of n becomes, or the limit of u of n becomes the minus 1 to minus infinity, and the b raised to n, so the equation becomes like this. So it is exponentially decreasing, so the graph becomes exponentially decreasing but discrete time from minus infinity. This will be not starting with minus 1 to minus infinity, so this is not the sample, so 0 will be omitted. Now minus 1 to minus infinity, we need to consider the limit of x of n for given Z transform calculation. So first of all, we'll start with the step 1 by considering the standard definition of Z transform. The step is same. The x of Z is equal to summation n equal to minus infinity to infinity x of n into z raised to minus n. But now there is a modification in step 2. So the now step 2 is considering the limit of x of n. So x of n will be, the x of n is equal to b raised to n. The limit of n now is n is less or equal to minus 1. So the now n limit is minus infinity to minus 1. So let's begin the summation. Now the x of z is equal to what? The summation of n equal to minus infinity to minus 1, and for that x of n is b raised to n. So b raised to n, z raised to minus n. But the limit over here is n is equal to minus infinity to minus 1. So if we consider this limit is the general limit, so we should answer it like this. So the one way to answer this example is by considering this limit from minus infinite to minus 1. So the solution of this equation now also becomes the n is equal to minus infinity to minus 1 b z inverse raised to n. So it is the considering the similar example like previous one, that limit is minus infinity to minus 1 a raised to n concept, but the limit is not 0 to infinity. Now over here the limit is minus infinity to minus 1, so we should consider the another power series example, that is the summation limit. If it is minus n is equal to some n1 to n2 value a raised to n, then it will be the a raised to n concept becomes the solution for this summation a raised to first lower limit, that is n1, minus a raised to upper limit n2 plus 1, and that is divided by 1 minus a, and the condition will always remain same. The mod a must be less than 1. So this type of limit n is equal to minus infinite to minus 1, for this we will consider this type of power series method. So to consider this type of power series, let's assume the x of z is equal to, now the summation is n equal to minus infinity to minus 1, and the bz inverse. So now our a is bz inverse, and the first annual limit is minus infinity minus bz inverse. The next limit is minus 1, so minus 1, and we should add one more, so it is plus 1, and then the final is 1 minus bz inverse. So the answer is bz inverse. Now the negative limit of infinity of any term becomes the 0, and the minus bz inverse raised to 0, so anything raised to 0 becomes 1. So minus 1 upon 1 minus bz inverse. So this is the limit, and if we consider this minus with this denominator term, so this will become the final solution as 1 upon bz inverse minus 1. So now this limit to sum of this bz inverse, the limit is bz inverse must be greater than 1. Now to make this bz inverse greater than 1, so this will be the z transform x of z, the final answer of given x of n, that is b raised to n u of minus n minus 1. So 1 upon bz inverse minus 1 is the final answer for given x of z. So let us consider the ROC comment or comment on ROC, the step number 3. How to comment on ROC? Now it is the condition given bz inverse is greater than 1, so it is the different from the previous example, that is a raised to n u of n. So for this bz inverse greater than 1, so if we consider this limit, So this will become the b mod b must be greater than mod z. So as 1 upon z, this is nothing but b of z inverse is also known as b upon z. So the denominator of z becomes the numerator of this right hand side. So mod b is greater than mod z. So this will become the idea mod z is less than mod b. It means the set of all z values which are less than the b radius circle. This becomes the ROC of given x of n, b raised to n, u of n minus n minus 1. So to plot this ROC, we will first consider the radius of b circle, and it is less than. So to consider the lesser part in z plane, less means the inner side of the circle. So these are the real part and imaginary part of z, and all the set of z values which are less than the radius b. So these are the inner part of the circle radius b. So this straight line becomes the region of convergence for given x of z 1 upon b z inverse minus 1. So if we consider the previous example was the a raised to n u of n, where u of n is totally right-sided sequence. So the ROC is the outermost region of circle or outer area of region of convergence. So we can see the difference in the second example, that is u of minus n minus 1 is the left hand side sequence, and now we are getting ROC is the inner part of the circle. So the difference is, or the significance of ROC is easily seen that the ROC can comment on the location or the existence of all the different type of signals. That if we say u of n is the right side sequence, then you can easily see from the ROC that this region of convergence is outer side of the circle. And for this u of minus n minus 1, the outer left hand side of the sequence, this will be the ROC which is inside the circle. So it is the significance of ROC that it will give the comment on signals in time domain. So it will give the existence of signal in time domain. So what would be the signal in time domain, whether it is right-sided, left-sided, or the mixture of both-sided. So this is the significance of Z transform as well as ROC in examples, and this type of examples will be asked in up to 7 marks. So it's very easy to get the 7 marks if we consider this type of steps, and if we straightforward this type of step 1, step 2 and step 3 in ROC, x of z, and considering the limits of x of n. By this we can easily solve the Z transform example.